So you start off, you'd work out your XL, work out your XC, and then start looking at your individual branches. So you've got your first branch there that's got your R and your L in it. So your Z1 for that, R plus JXL, 15 plus J, 37.7, then convert that into its polar form. So now you've got it in rectangular form and you've got it in polar form, so you can choose as you go forward. Then your second branch, this one here, if you like, that's your Z2 branch, which is just a minus JXC. So it's a minus J 26.53 ohms in rectangular form, and in polar form, if you look at your rules, 26.53 an angle of minus 90. And that should be your two branch impedances. Yeah? Do you get this? So it's a conversion. Is your calculator in degrees? When you look at the top of your calculator, in the middle wee bit there, it should, if there's an arrow on it, that's not any good to you. There should be a wee D on it. Is that a wee D? Right, so you're going, when you want to go from rectangular into polar, you go shift pole, then you're putting in the 15, comma, 37.7, close your brackets, equals. Obviously you can't see that at all. So that is mine. Pole 15 point and then a comma, 37.7, close your brackets. Then that gets me my R, which is my magnitude part, 40.57. And then if I scroll along, that's my degrees, 68.3. So then looking back, no problem with focusing today. This is now what you're going to try to do to get your parallel impedance, your total impedance. You're going to use that form there. So that formula there for ZT. So you're going to do Z1 times Z2 over Z1 plus Z2 . So because you're multiplying in the top, you want to be in polar form. And then you're adding in the bottom, so you want to be in rectangular form. So you're working on from that point there. So remember, when you multiply out your polar forms, you multiply the magnitudes, you add the angles. And for rectangulars, you just do like with like. So there's only one real one, just the resistance. Then you've got a plus J and a minus J. Now, once you're at this step and you're moving forward, because you're about to divide, you want to convert that bottom number there, from being a rectangular number into a polar number so you can divide it. So bearing in mind, you multiply and divide in polar, and you add and subtract in rectangular. Where would you be doing that? Multiplied? No, that's fine. Right, so convert that into polar. So that's what I'm getting for my Z total. Feel free to disagree with me in case I've made a mistake. So if you've got that, that's really part A of the question where it's asking you to work out the total impedance. Part B is asking you to work out the current, so it'd be the current there, the supply current. And it's the same as it always is. Instead of being I equals V over R, it's I equals V over Z. Because you're going to divide them, you want them both to be in polar form. Your voltage is your 200 at an angle of 0. And your impedance is that 57.56 at an angle of minus 58.37 that you've just worked out. And that'll get you the supply current. $33. And that'll get you that current. So there's nothing new there about that. Just for the whole circuit, I equals V over Z, use the supply voltage, use the total impedance in the circuit, and that'll get you the total current in the circuit. The next question asks you for the IRL, which is the current through here. And the one after that will ask you for the IC. Now, it's a parallel circuit. So for the IRL, you know the voltage there is the same as the voltage there is the same as the voltage there. So to get IRL, you can just do V over your ZRL, or your Z1, we've called it. So if you were going on to do your IRL, zero minus minus, zero minus, yeah, turns it to positive. That's probably the most common mistake people makes with that sign. So for your IRL, it's going to be V over your Z1. Because your Z1 is your impedance in that RL branch. And your Z1 you've already got in polar from earlier on. It's been 40.57 at an angle of 68.30. 4.93 an angle of minus 68.30. For your IC, it's going to be V over Z2. Your Z2 is your capacitor branch. And that was the value of the impedance in that. And again, 0 minus minus 90 gets you a positive 90. They're both currents, so they're both in amps. The next thing you're asked is the voltage across the resistor. So, looking back at your diagram there, you've got the current through your resistor. You've got the value of your resistor. So to get the voltage across your resistor, you're just going to use V equals IR. Because the impedance of your resistor is the resistance itself. So the voltage across the resistor is just going to be IRL, because that's the current through it, multiplied by R, because that's the impedance of it. Your IRL, you've just worked that out not long ago. That's it there. And your resistance is 15 and angle is 0. Remember, resistors are either 15 plus J0 or 15 at an angle of 0. Multiply the magnitudes, add the angles. It's all the same rules that you had in a DC circuit. Voltage, so it's measured in volts. F, voltage across the inductor, VL. Let's have a look at where L is. So L's down here in this IRL branch. So we know that that's that. So it's going to be IRL again. And it's not going to be times by R, it's going to be times by your plus JXL. But because you're going to multiply it, you don't want it in polar form, you're going to have that in rectangular form. So it's the same current, the 4.93 at an angle of minus 68.3. But your XL, which was 37.70, and if you go back to look at your rules, for an XL, the angle would be 90 degrees. I absolutely did mean to put in polar form there. I don't know what my brain was doing to me there. You want it in polar form because you want to multiply it. So that there is polar form. Sorry about that. So again, multiply the magnitudes. And add the angles. Difference in rounding or just a difference? Right. That's all right. Now, if you wanted to check these, then what you would do is you would convert that into polar form, add them together, and then you should get your supply voltage there, because you know the voltage across there and the voltage across there should add up to give you the 200s. And if you wanted to check the currents, similarly, you'd convert that to rectangular form, that to rectangular form, add those two up, and you should get that when you convert it back into polar form again, that bottom one there. So there are lots of checks you can do. but that's pretty much the bare bones of it.